Okay. Good morning, and today we're going to be looking at three-dimensional figures with three straight sides. Again, a three-dimensional shape can be viewed as two-dimensional shapes given a depth. The volume of the shape is the surface area of a base times the depth or the distance between one base and its parallel base. So in this hexagonal three-dimensional figure, we have our hexagonal bases separated by this distance here, our depth. So, and the surface area of all 3D shapes are the sum of the areas of each face. So we're interested in finding the surface area initially of a figure like a cube. So a cube has 6 sides or 6 faces. Each face is one smooth or flat surface, and those sides have a length times a width, or in the case of a square, the side length squared. So if we let our side lengths be 2 inches, we have 6 times 2 inches squared. 2 inches squared is 4 square inches, times 6 is 24 square inches. A rectangular block such as this orange block here has 6 sides, but it has a pair of sides that are one set of dimensions, a pair of sides that are another, and a third pair of sides that are another still. So we have 2 sides that have a length times a width, 2 sides that have the corresponding length times the depth, and 2 sides that have the corresponding width times the depth. So we have a width of 1/2 inch and a length of 1 inch, a length of 1 inch, a depth of 4 inches, and a width of 1/2 and a depth of 4, gives us a surface area of 1 square inch for the 2 thin sides, 10 square inches for the 2 largest sides, and 4 square inches for the long narrow sides, for a total in this case of 15 square inches. Again, we have 6 faces that come in 3 pairs. The surface area of a triangular prism needs to be determined by the surface areas of the 2 triangular faces, which is 1/2 base times height. Remembering that the base and height need to be mutually perpendicular, plus the area of each of the faces, which is going to be the length times the width for each of the 3 faces, length 1, width 1, plus length 2 with 2, plus length 3 with 3. In this case, they all happen to be the same length and width, but they don't have to be. So our base is going to be 2 times 1/2. Our base is going to be this whole length here, 0.75. Our height is going to be 5 divided by 2 squared. Our height is going to be 0.86 plus our length is going to be 1 times our width of 3 for each of our 3 sides here. So we have 0.75 times 0.86 plus 3 plus 3 plus 3 gives us 9.645 inches squared as the surface area of this triangular prism. But what about the surface area of a figure such as a hexagonal prism? Finding the surface area of a hexagon requires a little bit more thought. Here we have a pentagon, and our green lengths connect from the center of our hexagon to the point or vertex of the pentagon, and our purple sides connect our central point of our pentagon to the midpoint of each side. The purples are shorter than the greens and give us a height of 7 centimeters. That is the height of a triangle made up of our 2 green sides plus our orange sides. The combined length of our orange sides of our 2 orange pieces is 10 centimeters. So this pentagon, this 5-sided figure, can be broken into 5 separate triangles of base 10 and height 7. So we have 5 times 1/2 base of 10 and height of 7. So 5 times 5 is 25, times 7 is 175 square centimeters. So with a hexagon, we're going to need to do the same thing. Find our distance from our center to our edge. So we're going to say that that is 2 centimeters. The width of our base is going to be narrower in this case, and we're going to go with 1.8 centimeters. And we need to make 6 triangles. So we have 6 times 1/2 of our 2 times 1.8. 6 times 1/2 times 2 times 1.8 gives us 10.8 square centimeters. So we can think of the area of this hexagon that you can't see as 10.8 square centimeters. 6 triangles, each with a height of 2 and a base of 1.8. So we have 10.8 as the base of each height, the surface area of the 2 parallel sides, plus we have 6 sides that are each rectangular in nature of 5 centimeters by 1.8 centimeters. So we have 5 times 6 times 1.8 gives us 54 centimeters squared. 2 times 10.8 is 21.6 centimeters squared, or 75.6 centimeters squared is the surface area of a hexagonal prism. A pyramid, again, has 5 faces, and 4 of those faces are triangles, and 1 is a square. So we have a square pyramid. Is going to have a square base plus 4 triangular side faces. So our square base is 2 by 2. Our triangle, we have 4 of them, with 1/2 our base of 2 and a height of 4. 2 times 2 is 4 inches squared. 4 times 1/2 is 2 times 2 is 4 times 4 is 16 inches squared, or 20 square inches is the surface area of this square pyramid.